Hey everyone, it's Malcolm, and welcome to yet another daily data drop. So, DeepSeek recently released a new model, DeepSeek V3.1, and I was trying to figure out why there was so much excitement around DeepSeek when, from my personal experience, it either performed a bit worse on certain tasks, or in some cases it did perform better, such as in reasoning and writing. But in terms of code and complex tasks, I felt its performance was suboptimal. So it was a bit confusing to me to see why people were getting so excited about DeepSeek. So I did a little bit of digging, and I'm going to be sharing everything I found out with you today. So the verdict for DeepSeek is that it is really good in comparison to other models in terms of how fast it is able to produce its answers, especially for more complex tasks. And the magic behind this is due to something called Mo. And before we get into who or what Mo is, I'll need to explain TTC. So, TTC, or test time compute, is when a machine learning model is intelligently allocating computational resources during its inferencing or prediction phase, and that would be anytime you're using it outside of training. All this means is that the AI is thinking harder about new or complex tasks, especially things that may fall outside of its initial training dataset. So we can categorize machine learning models into TTC and non-TTC. So TTC models are models that have dynamic inference. All that means is when it's creating an answer to your query, it's dynamically allocating its computational resources for complex or new queries. Oftentimes, this actually involves creating multiple potential answers to your question and refining and finding the best solution before you ever see the answer. And that makes these models far more adaptable, and they're able to more accurately respond to novel, complex, or ambiguous queries. The only drawback would be the cost. These models use a lot more computational resources, so yeah, they have a higher cost per use. On the other hand, non-TTC models use a predetermined fixed amount of resources when answering your questions. This means they have faster, more immediate answers to your question, but they have static reasoning, and outside of their training data, they tend to struggle a bit more. However, the positive side is that they're a lot more affordable because they are using fewer computational resources when answering those questions. But at the same time, this makes them far less adaptable, and they're not able to handle those ambiguous queries or new situations it may encounter. So this really gets to the root of why DeepSeek generates so much hype. Even though it only performs slightly worse and in some cases better than other models, well, that's because DeepSeek typically is non-TTC, depending on which version of it you're using. And it's being compared to TTC models, but it's able to answer almost as good, if not better in certain cases, but it does it a lot faster, cheaper, because it's using less resources. So, how does DeepSeek do this? To help really show the difference between DeepSeek and other models, I'll be comparing DeepSeek V3 to ChatGPT 4. DeepSeek being non-TTC, GPT-4 being TTC. So the first thing we'll do is to compare the size of each model. And the best way to compare size when it comes to machine learning models would be using parameters. Parameters is simply a set of weights and balances that just determine how the model predicts the response to your query. So DeepSeek has 687 billion parameters. And that may sound like a lot, and it definitely is, but in comparison to GPT-4, it's actually not. GPT-4 has 1.8 trillion parameters, but the way they use these parameters are very different. So, although DeepSeek V3 has 687 billion, when you ask it a question, it only uses 37 billion of those parameters in order to answer your question. However, ChatGPT-4 uses all 1.8 trillion for every single question you ask. What this means is that DeepSeek is intelligently selecting the most relevant parameters to your query before it starts to answer, rather than like other non-TTC models using all of their parameters. It's able to select exactly what it needs to create a more accurate answer relevant to your query. This makes it blisteringly fast and still more accurate than competitors with a comparable amount of parameters. And it's able to perform closer to the results of a TTC model. This design is known as the mixture of experts, or MO, design. On the other hand, ChatGPT-4 uses all 1.8 trillion parameters every time you ask a question, and this makes a high TTC a necessity. It needs a lot more computational power to determine the best answer using all of those potentially unrelated parameters. And that's why it needs multiple iterations until it comes up with something that best answers your question, because most of those parameters likely have nothing to do with what you're asking it at that time. Anyway, I know that was a lot, but I hope you learned a lot from this, just like I did when I was looking into this. That's it for today, and I can't wait to see you tomorrow.